Hello, everybody, and welcome to the Node API team meeting for March 5th, 2021. Unless there are any announcements to make, please make them now if you have them. Otherwise, we're going to get started with the agenda. So going once, going twice, gone. All right, agenda it is. So then, screen sharing is about to start somehow. Geez, this thing has changed. Oh, there it is, share screen. Okay, share, and we go to the milestone. Can everybody see this?
Yes.
Yes.
Okay, good. All right, so renaming an API, let me see what has been going there. We've done, I think, tests and docs. And Jim, I saw you did something on API stable node. You having had the last commit there. So let's see what else is missing. It's a good checklist. So let's see, no JIP. So you did no JIP as well, eh?
Yeah. Oh, right. Node.js does not refer to NAP or Node API.
Oh, okay.
Directly.
I see. Okay.
So,
yeah,
okay. I just need to get out to those other projects. The other thing I noticed is I don't know how it happened, but the Node API resource, the tutorial site did not get updated. So that is next on my list.
Okay. All right. Sounds good. Okie dokie. So then, let's see here. Okay, blog post about transition to Node API. Okay. All right. Okay. So I guess we're working on this. Do we have like a Google Doc for this?
Not yet. If you want, I can prepare and send you the link.
Okay. Yeah, that'd be good.
I will send only to the team member, and maybe after we will make public all the content.
Yeah. Okay.
Okay.
Yeah, that sounds good. Thank you. Okay, so then, wait, let me make a comment about that. Well, maybe I won't because it's public, but whatever. There we go.
Yeah.
All right, so there we go. We got the article going. All right, stale issues. All right, let's see. Let's see here. Oh, let's see. Oh, sorry. Page down. Still getting used to this computer. All right, so these three are new. Well, new ones to discuss. So let's go for the first one. Data lifetime for buffer and array buffer.
I'm working on this, but I did not end to yeah. I need another week to give you a solution or my strong opinion about this problem.
Oh, wait a minute.
But
Okay, I see. Oh, yeah, we don't have a finalizer. Is that the problem? Is that these
I saw on the Node core repo, and in this case we don't call a finalizer. No, if you just create the buffer using napi underscore create external buffer.
Yep.
And we never called the finalizer. So yeah, we never released the
So okay, so wait a minute. Let me see if I understand this correctly. So the core API doesn't call the finalizer, or Node add-on, or the core API calls the Node add-on API finalizer, but the Node API finalizer doesn't call the user's finalizer. Is that it? Which one is it? Is it the first thing I said or the second thing I said? The problem.
Okay.
So okay, let me try to rephrase.
Yeah.
Does the core part of it work? Just here.
I'm not sure, because in the core we use
Oh, whoops, sorry. Okay, so this, right?
Yeah, this. But
okay, so this here, right? This finalized CB. So if you provide a finalized CB, then does it end up getting called?
yeah, this is the problem, because yeah, we okay, if you provide the finalized CB, yeah, the finalizer will be called, and you can release and destroy the data if you want, no?
Yeah.
But when you
Let me just open the code. Go ahead.
when we use on Node.js API, yes, we don't provide
Oh boy.
yeah, we don't provide a
Finalizer.
yeah, an empty finalizer, so that call, no, is to release the data, and
okay.
this is the problem for me.
Well, but we
But
hold on.
but the question, no, the is is about who take this responsibility to release the data, no? It's not the Node API responsibility, or not?
Well, I don't think we should, because you don't know what mechanism was used to allocate. Was it malloc? Was it mmap? What was the mechanism, right? So you don't want to like call free or delete, right? Because who knows whether that does the right thing, But like,
because I don't know who uses that data, and if yeah, and how. So yeah, the implementation that we provide, it could be okay, but we need to document like minimum, no, this behavior. So
we don't. Okay, yeah, we don't have these things documented, like these methods, because we have two methods here which each take a callback, right? Like we have this one here, right? Which accepts.
but maybe developers could think that, okay, they provide a default finalizer that delete the data for us.
Oh, I see.
So yeah, this is the problem.
Okay.
In
So
my
they don't
opinion.
know. They don't know that if they don't provide a finalizer, the data will not be destroyed.
Yeah.
Oh, yeah. Okay. Yeah. So then we need to
So,
document that.
so maybe the only thing that we can do is to document this.
Yeah. Makes sense. Yeah.
Uh,
So we have new. Oh, I see. Okay. So we have these, and then here. Okay, so there's this one and this one, right?
Yeah.
Okay, well,
But,
this one here is our under, whoops, this one here is under our control, right? Because this creates a new buffer. But this is not under our control, right? This is data coming in from the user. And so here we have to say that this data will not be freed, right? So here basically, like here maybe like between these two, like add a warning saying like, you know, this data will, you know, will not be freed if like if you wish to be informed that this buffer will be destroyed and you wish to free the data at that time, then don't use this method, use this method here, right? Or this one.
okay,
So
so I
that's
can I can work on this, and yeah, I will add this on the buffer and array buffer documentation, because on the
right.
on the array buffer we have the same problem.
Okay.
Yeah, you can comment about the discussion that we had.
All right.
Yeah.
There we go. Okay, understood. Okay, so yeah, it's good to point that out. Okay, so that was this guy, and then 8:30. Oh, the iterator. Okay, right. So, what have we been gotten with this? And it seems reason, but might be due to sparse arrays, etc. Okay, yeah. Okay, so this one is status quo because the person has not yet reacted to Michael's question. Okay, and lastly, okay. Oh my goodness. Whew. Yeah, this is a big
it's
one.
for you.
Yeah, I don't know if we can make any progress with this. Yeah, they haven't reacted. I guess these two folks, they're not really involved with V8 anymore, or at least not this portion of V8. Yeah, I don't know if this is ever going to happen. Like, it's basically up to V8 to provide a way to do this. Otherwise, it's very, very hacky, and yeah, there are just some fundamental issues with this. I'm not sure if we can ever do this, but it's good to keep it open because who knows what V8 is going to do. And then if they do the right thing, then we can just jump on it and fix this issue. So yeah, that's basically where that's at. Okay, and that was the stale issues.
Well, maybe we can remove it from the list.
Yeah. Okay. Yeah. Yeah.
The 830. I don't know if it's.
Wait.
It's
was it this one? Is this the wrong one? Oh yeah, no, wrong one. Yes, thanks. Thank you. Okay, yeah, it was this one. Yeah, substitute for inherit. Right. Oops. All right. Yeah. Okay. So then we return to the milestone. Okay, so tracking issues. Wait, yeah, that was tracking issues for modules. Okay. And okay, no news here, but this is the time to check npmjs.com package node.api and see where we're at. Hot diggity dog, we're almost to 4 million. Well, well, well.
That's pretty amazing.
Yeah, cool. All right. Well, maybe next week.
Yeah. Yeah,
right.
for sure. Yeah.
Yeah.
Okay, this is good. All right. So having recorded that, let's move to external examples. I'm afraid that's a status quo, but I think the PR got merged, right? So it is where it is, and we can always fix it up. And I mean, it seems like it's you know, it's an active repo. So you know, if there are issues with it, they may come to our attention. All right. Let's see, enable debug testing. Yeah, I don't know if Michael had any chance to work on this. Otherwise, it's status quo. And then module owners. Okay, so those were new issues. Now let's look at, or those were old issues. Now let's look at new issues. So GitHub, Node.js, Node add-on API issues. Okay, is it possible to store buffers without copying? And confusion about instance data handling. Ah, well, instance data. Currently trying to build an add-on using Node add-on API. Or sorry, yeah, however, I'm completely about the idea behind set instance being a template suggests that you could set multiple data-ons of different. No, looking at that always, yeah. So this that's right. It says no add-on API invokes add-on init, which in turn calls with the yes. This means that it is impossible to inside. That's right, because this would be over. Yes, okay. Okay. Since this is a question, this is an answer. And so if they're dissatisfied with the answer, they can reopen.
Yeah.
All right. There we go. Close with comment. All right. Good. Yeah, that's great. Yeah, people are using these things. All right. Let's see here. Templated class instance based on JS constructor. Oh, haha. Yeah, I don't know if you can do that. Right, with different types depending on user input, something like this. Okay. Yeah, that's. I don't know if you can do that dynamically. Yeah. Okay. Now I don't know about that. Someone intercepted construction. Okay. No. Okay.
But essentially, T is an API value.
Yeah, exactly. But the problem is that C++ templates are instantiated at compile time, right?
Yeah.
And so at compile time, you cannot know what value will be coming in at runtime. So basically, you'd have to do a switch. Like if is date, then date. If is then right? So there's no way to do this dynamically. There's no way to instantiate C++ template at runtime. The only solution is to gauge what kinds of types may arrive into the constructor and do a switch for each type that can be handled. CPP, and then you say like if input, no, it's not in, it's info, right? Yeah. No, it's well, if info 0, I think you can as object, right? And you can probably do this.
But
type is string, right? Something like this.
Yeah.
And then you say, okay, what the hey? Else if home something like this.
Maybe you can use number, no? You is number. So yeah, okay. So
there.
Yeah.
All right. Okie pokey. All right, so there's that one. All right, so yeah, this one, how to implement custom inspect into, okay. I tried registering how to custom into object wrapper class. Okay, I think, okay, it looks like Kevin's on this one. So, okay, let's let Kevin handle this one. He seems to have become involved in the conversation. Okay. All right, okay, I see. Oh, that's not bad. Okay, right. I put that into a function. And then, thank you. Okay, so does this work for him? I tried to instance method, right? Oh, I see. Okay, so no, it's not symbol new. You need get public symbol. Okay, got it. Have you tried otherwise? Okay, symbol 4. Okay, yeah. Differentiate from JS right. Okay, yeah. This is interesting. Why does this return undefined? Maybe this doesn't work correctly. Like it seems like there's a problem with an API symbol well known, right? Well, let me ask Kevin. There we go. Because then it makes sense to keep the issue open.
Okay.
We have a problem because this person might not have needed to write this function if this had worked correctly, assuming this is what it's supposed to do and doesn't. Okay. Go ahead, Nicola.
No, yeah, you're right. So
All right.
we need to investigate more.
Yeah. All right. So let's see here. Okay, that's how to pass a callback to an object wrapper to be executed async by an whoosh. How to pass a callback to an object wrapper. Okay, I think. Okay, that provides a facade that allows me to register callbacks to listen for. Okay, my approach was to create a facade wrapper. Yes, in the facade wrapper, I want to make available. Yep, that's good. Once the callback, okay, it will be fired out. Yep, it's typical usage. Yep. Okay, so, all right, let's see. What do you do here on entity update? Scope. Yes, good. Good. Yes, using a persistent. Oh, wait a minute. The method owner belongs to the X. Yes. Okay, and avoid star, but not this. So, okay, JSCB is, okay, is that? Yeah, okay, pretty reasonable. Yeah, is this getting called on the same thread? Because if not, oh, the handle scope thing. Oh, yeah. Okay, right. Yeah, and in your library, yeah, then you need that. Okay. Yep. Okay, let's see if there are any problems. Okay. Right. Okay. All right. Looks like Kevin's on this one. Yeah, we'll let him handle it. Yeah. Okay. Yep. Okay. Yeah. Okay. That's good. All right. Let's see here. Okay. Memory leak. Oh, okay. So this is the one you're handling, right? This finalized callback.
Oh, this is this is a new one, but yeah, it seems
Okay.
that
Yeah. Oh, wait a minute though. Cleanup hook.
no, yeah, this is another issue.
Huh. So. Okay. Well. Okay. Let's see what they're doing here, right? Because like. This may or may not get called. Well, it actually should. Well, it depends on the version of Node. Yeah. Okay. Let's try. Okay, okay, all right, all right. So okay, it matters what version of Node this is because on old versions, and is this happening in a loop? Oh, while true, okay. I see, okay. So this is in a loop, eh? I'm passing an array buffer from C++ to JS. The public one gets called. Oh, on program close, yes, okay.
Yeah.
Okay, yeah, okay. So then they're probably using the latest version of Node, which does the env cleanup. Okay, so there's the malloc. Yeah, interesting. Okay. Okay, yeah, all right. Yeah, it looks like Michael's handling this one. Yeah, we've had issues with this before, where the timing of the call was such that it created a lot of pressure if you did it in a tight loop. Okay, store buffers without copying. Okay. Store buffers without copying. Right. That's lost when the function ends. Well, well, well. Yes. Yeah. That's right. Yeah, exactly. Yeah. Well, yeah, because you've got references to buffers. That's why it's using a lot more memory. Let's see what Lucas said. Yeah, yeah. Yeah, exactly. Yeah, yeah, I think that's the best we can do. Yeah, okay, yep. Yep, Lucas, I think you got it covered.
Yeah, just waiting for the OP to maybe respond.
Yeah, yeah, but yeah, I think there's not much we can do. Either you copy the data or you store a reference to the buffer. There's just no other way to prevent it from being destroyed. So yeah, let's see what they say. Okay, okay. This is yours. Getting clear assumes. Yes, that's right. It does. Yeah. Yeah, yeah, yeah. I think I posted to a link to this issue here. So that's basically why we do this. Is that yeah? So there are two issues here. First of all, we need to whatever it is that you throw has to be a reference because let's say you have a call and inside the call you do your handle scope. In there you throw an error, right? Now the error is a C++ exception, right? And so the C++ exception will cause the frame in which it was thrown to be destroyed, right? But when the frame is destroyed, the handle scope is closed, and so the value you created in that frame is also destroyed, right? And so then is destroyed by the engine, not by the language, right? And so then you cannot put it back into JavaScript unless it's a persistent reference. Now, the second problem is that we decided early on in NAPI that persistent references can only be made to objects. We cannot have persistent references to like a string or a number. It's an interesting limitation. It's certainly not a problem with at least V8 and JavaScript. I know both of them can have persistent references to primitive values, but I suspect that the reason we limited it is because some engines couldn't. They can only have persistent references to objects, and so that's like the lowest common denominator. And so that's how we ended up with this limitation that these things can only be objects. I had an idea for how to get around this. Lucas, if you want to spend some time trying to maybe explore that, or maybe I can if I can find the time, which is to, you know, when you attempt to construct an error using a primitive value, right? Then you construct an object, but you somehow mark the object in such a way that, you know, when you throw the error into JavaScript, you know that, oh, this is like a special kind of object, and so instead of throwing the object itself, you throw like one of the properties of the object back into JavaScript. And so it's kind of a workaround. I'm not sure if it's possible to do it cleanly, but this is one way we might be able to handle throwing, you know, just any sort of primitive value. But I haven't had any chance to try to explore that. And so then, you know, so you have an object with a property, and the property is really the thing you're interested in. Yeah.
Actually, we have been using we have been seeing a similar case in JavaScript. You know that in JavaScript, the primitive values are like numbers, small numbers are encoded into the value pointer directly. So in that case, there is a phenomenon that the value 0 is treated as a you see in Node API, if you return a null in a C++ function to JavaScript, you'll get actually a null in JavaScript, right?
Yep.
And in that case, in JavaScript, the 0, the null in JavaScript means the primitive number 0. So if we have to keep consistent behavior between the Node and the JavaScript Node API implementation, we have to wrap every 0 or maybe some other case to present that it is a 0 or it is a null. So we found that there have too many cases that the function, the C++ can interact with JavaScript, like say we return from it and we assign it into a, you can assign the value into a property of a object, right?
Yeah.
So in that case, we have to unwrap it and assign to the object, and we have maybe some like say throwing it. So there are too many cases we have to wrap around it. So the overhead might be unacceptable in the case. So there are too many wraps and unwraps around the value. So I'm very like say I'm not sure it will be a feasible solution to resolve the problem.
Yeah. That's a good point. However, one thing that I can think of is that since we're talking about errors, right? You know, if you're in a situation where you're throwing many errors, very in a very tight loop, then that's maybe not a good way to run a program, right? So I guess what I'm trying to say is, if you're about to throw an error, you're already in an exceptional situation, right? And so, so now you're saying that, okay, I have to throw an error and I have to wrap and I have to unwrap, right? And so you're saying that may be unacceptable, but that's only unacceptable if you do this a lot. Whereas, you know, the fact that you're throwing an error should mean that, you know, the program is about to end, right? Like, but then of course you're right. It depends on the use case. I'm just saying that, you know, if we did this in like an object wrap constructor, then I would understand that you don't want to do an extra wrap. But since this is an error case, you know, is it really that bad? Like, do you have a situation where you have to throw like 100,000 errors per second? You know, if you do, then you're absolutely right, and it's not worth doing the wrapping. You know, but you got to think about it like it's an error. Things are about to die. You know, so is it really so bad that we do an extra wrap before it all comes crashing down? You know,
I'm still hesitant about the statement on the exception case, since exceptions in JavaScript are very common code that we may be wrong. So in JavaScript, those exceptions are not fatal errors. The program are expected to continue to run on the exceptions. So we may not assume that once the exception was thrown, the program is expected to run a very strange conditions. So I'm still hesitant on adding much overhead to the code path in throwing path. So and the Node add-on API is the very low basic packages to native add-on developers. So the magic added to Node add-on API may be very hard to you see hard to understand to those native add-on developers, since the Node add-on API are very basic packages, you know. So I'm still hesitant on adding the such a magic solution to the package.
Yeah, absolutely. You are absolutely correct. Yeah, in fact, we should probably encourage add-on developers to throw proper errors, right? Like objects of JavaScript type error, because that is good practice, right? And so yeah, we should, because I know in pure JavaScript world it is also discouraged to throw things that are not error objects. You know, throw strings, throw numbers. It's discouraged. So yeah, if we, you know, we can simply come down saying that, yes, sorry, we don't support that because it's bad practice anyway. And so, you know, and you can, you know, if add-on developers want this, they can definitely add it themselves, right? Like if they want to go so far, they can, right? They can do this wrapping themselves. We don't need to do it. You know, they can throw they can throw a string. They can write their own utility for throwing things, you know, which does the wrapping. So, you know, if they absolutely, totally, completely, unequivocally need this, then we can help them out by, you know, here's a utility that you can write that does this for you, and then you have to change your binding to put everything inside a try block, and then, you know, and then throw just a regular value, you know, or even just write like a JavaScript function which is written in pure JavaScript, which you pass in, and then you pass in the value, and then the function throws. You know, it's so basically wrap like a JavaScript throw statement into a function, pass the function to your native library, and then you can throw whatever you want. You know, so there are solutions if they absolutely need it, right? But by default, we are discouraging this. So yeah, okay, I agree with you completely. Okay. Yeah. Okay. So we can stay with that. Okay. So then, you know, can we close this issue? Since you posted it.
You know, there might be, the crash might still be unexpected. You know, there might be cases that I'm still
Yeah, we should document this. Do we have documentation about this? Because like, yeah, where is this? Yeah, we should document. We may need to update the documentation that you can't just throw anything you want. Okay, so there, doc, and I think, is it error?
I was thinking that maybe if it is possible by using a build flag to control if the error is being referenced, if the exception value is referenced.
But it has to be though, right? It has to always be a reference.
It has to be a reference in the case of C++ throw exception is enabled, and if the C++ exception is not enabled, we don't have to reference the value, right?
Yeah, that's true. That's true, but
and most of my I've seen the use case of Node add-on API. I've seen those projects not enabling C++ exceptions. So I might say that for those cases, if we can to reduce the risks of the program from crashing.
Yeah. Okay, so we have this. Throw as JavaScript exception, right? Yeah. But yeah, so we're kind of forcing it a little bit here, right? Because we're making this like an instance method on error, right? Which means you have to have constructed an error in order to throw anything. But in pure NAPI, in the C library, you can throw any NAPI value, right? So this is an artificial restriction.
I mean the exception values we have caught from the JavaScript, and you see in the issue examples, the crash is not initiated from the C++, but it's initiated from the JavaScript, right?
Yes, because it's get and clear exception. That's true. And then, yeah, that's a good point. Right. Yeah, and then it tries to do that as an error. Okay. I see where you're getting, where you're going with this. So then correct me if I'm wrong. We may want to change get and clear exception to return just a plain value, right? So instead of returning an NAPI : error, we may want it to return like an NAPI : value if C++ exceptions are turned off, right?
Yeah.
Okay. Yeah. Do you think you can do a PR with that? And then
I may find any time to do that. I would like to test it if it solves most of the case if the C++ exceptions are disabled.
Yeah. Okay. Let me just write this thought down. Is it? Nope. We still kept the team, I think. No, we didn't. Oops, what the heck? And only if section is turned off, making clear in the documentation that making clear in the documentation the implications of not having a persistent reference implications with respect to handle scope of not having a persistent reference. Okay.
Sounds great.
Yeah. All right. Okay. Since we only have 5 minutes left, I'd like to talk about one issue in core, which is, I forget what the issue is, but you brought it up. You have a repro for it. Do you remember the issue number? But in case you don't, because I have a solution for that. Issues, labels, Node API. Okay. All right. This one, right?
Yeah.
Okay. So, there is a solution. One thing we forget to do during the environment teardown is to clear weak. So in a way, during environment teardown, we're saying we are responsible. An API is responsible for running the finalizer. So, JavaScript engine, stay out of my way. I am going to do all the finalizing, right? But in order to do that, we have to clear weak, right? We have to tell VA to clear weak because there is a chance, as you have found, that the garbage collector will still run at some point, right?
Yeah.
So then it's a good idea to clear weak and only then call the user's finalizer, right? And so I have a branch with that. I don't have, I have to take your repro and turn it into a test. I haven't done that yet, but basically this is the idea. On the other hand, there is another aspect to this. In your repro, the only reason why the garbage collector runs during environment teardown is because you call it, right?
Yeah.
So under normal circumstances, the garbage collector will never run during the finalize all loop because the finalize all loop is running. So the garbage collector cannot run, right? Because control is inside the loop that says, finalize reference, finalize reference, finalize reference.
What if the finalizers call JavaScript and the JavaScript reached a case that triggered the garbage collection?
Yes, exactly. Thank you. Okay, so let me see if I understand this correctly. In your reproduction, you call GC explicitly, right? But
yeah,
if I understand correctly, what you're saying is that if you call any kind of JavaScript, whatever, not necessarily GC, then a GC can be triggered and a GC can run before that call to JavaScript returns. Is that what you're saying? Yeah. Is that correct? Okay, I see. I understand. Okay, so then we need this solution, right? And
yes,
but we kind of don't need the solution in 15 and in master because JavaScript execution is disabled during environment teardown, right? So that's why we didn't see this problem.
And
we're only
there is a simple workaround for this. Like say we can force the GC to be run on the process exit event. So the weak finalizers are definitely to be collected on the exit event. So that's a simple workaround for the issue. So there is no rush to resolve the problem, since the problem is only to be crash on. There are chance to crash on the teardown event. Teardown.
Okay. So you found a workaround. Okay, that's good. But I think we should still do. Let me show you what. cd.node git branch. Okay, git diff. No, git show. Okay, so this is what I'm thinking. This is basically the solution. So this is finalize, right? And one thing we should do just for safety is this. So you copy the finalize callback, you set the finalize callback to null, and only then do you call it, because we're inside this, right? So this will make sure that the finalize never gets called twice, no matter what happens. Because I've seen this happen. Like your repro causes this finalizer to get called twice, actually. Once from environment teardown and once from GC, and that's bad, right? We should never call the user's finalizer twice, and this will make absolutely sure that we don't. And then this is an override for this method here, which does the clear weak, right? To make sure the garbage collector is out of the loop. We don't want the garbage collector anymore, right? And then it chains up, and then this runs. So okay, so I'll keep working on this. I'll add your repro, which does absolutely nothing in master. In fact, on master we have to handle the exception that you cannot call into JavaScript. So it has to behave differently on master than it does on 14. But when we backport this to 14, then this should fix 14, and then you should no longer need to use the workaround in 14. So is that a good plan?
Yeah.
Okay. All right.
I have another question. I've seen the comment that you put on the ref base delete method. That there is a chance when we clear the weak but the V8 has already killed the weak callback. So I have no idea that if the case is effective effective here.
Wait, are you talking about this method here?
Yeah, the comment you have put above.
Yeah. This here?
It's on the
Okay, so let's see. The second way this is called is from the finalizer and delete self is.
It's the second phrase in the second paragraph.
Oh, this here?
Let's say, no. If the finalizer may have been killed and has not already run, delay the delete until the finalizer runs by not doing the delete and setting. The cursor down.
Oh, here. Yeah, here.
Yeah, this sentence.
Yeah, okay, yeah. If the finalizer may have been queued and has not already run, delay the. Yes, okay. Okay, yeah. Until the finalizer runs by not doing the delete. Yeah, okay, yeah. This is if you have a weak reference and you explicitly call delete on the weak reference, then you cannot actually delete it until the finalizer runs, because there is a finalizer. And if environment teardown happens before the finalizer, then it's not the engine that runs the finalizer, it's the environment teardown that runs the finalizer. Either way, we have to remove the finalizer from the engine. We have to clear weak so that the engine doesn't run it as well, you know? So either way, you have to do the clear weak.
Yeah, I'm wondering if is there any indication that once you see when V8 have included the finalizers and we run the delete, your fix and just delete the reference, and the finalizer is still being queued and is still going to be run.
Well, I'm assuming you're right. I'm assuming that if I say clear weak, then V8 will do the right thing, meaning even if the finalizer is queued, it will remove it from the queue. So you're right. If it doesn't, then this doesn't always work.
Yeah, I was confused by the comment of this sentence, since it indicates that when we clear the weak, the finalizer is still being queued to run. So
no.
Sure
This is much older, right? This covers a different use case here. This covers the use case during regular execution, not during teardown. So that's why we have this. That's why we have this sort of ping pong between delete and finalize, right? That covers the regular use case. This here, where is it? Here, this thing. This is something that is not yet on master. This is something I added to fix to address your repro where the GC may run. And here I have to clear the weak because no matter what happens up there, we don't want the garbage collector to run finalize at the same time that a tilde NAPI env runs the finalize, right? We don't want that to happen because that's exactly what happened. What happened was finalize all from tilde NAPI env calls GC, which calls finalize, you know, which returns, and then execution continues right about, yeah, then, okay, so then this comes back, right, after having run this already, and then here, these members are already free, and it crashes here when you try to delete, because that's a double free. So that's what was happening. But the other thing we can do, the other thing we can do, I suppose, well, no, we can't really do that. Like if you don't want to clear, then you have to add yet another sort of flag that says, you know, the finalizer called from the GC, because you can tell whether it's called from GC or not. If it's called from GC, isEnv teardown is false, right? So you know, we can say like inside finalizer or something, and then if you call finalize again and inside finalizer is set to true, then just return. That's the other way. But you know, well, actually, that doesn't seem like such a bad solution, actually.
So if the V8 is behaving, if the V8 will not call the finalizer if we clear the weak, then we don't have to do such a.
That's right. But is it guaranteed not to call the finalizer if you clear weak, right? V8 is not under our control. This code is under our control. So. So now that I spoke about this with you, I'm beginning to realize that maybe we should use like the inside finalize thing instead of clear weak, because clear weak may or may not be effective. Who knows? Maybe a later version of V8 will still call the finalizer even if you call clear weak. I don't know, right? But I can be 100% sure that I'm not going to run this twice if I use that Boolean, right?
But how do we determine that the reference is already being actually deleted while we cannot access its member, and how do we determine if we are going to delete it with the parameters, the EMB teardown?
Okay,
since we cannot access its members.
Yeah. That should not happen, right? Because okay, so basically what we're trying to do is we're trying to make env teardown be identical to GC. That's the goal, right? Is env teardown looks exactly like GC, right? Meaning that finalize runs and finalize may or may not call delete, right? Because if the code inside, if the user's code says NAPI delete reference, and we call that from finalize, then we have to do this deferring thing, right? But if it doesn't, then it still has to be deleted afterwards, right? So this is what we have to achieve, and we have achieved this in most cases, except in this case where the GC where the user's finalizer runs JavaScript. JavaScript is allowed to execute. JavaScript causes a GC, and the GC causes a finalize, right? So in that case, we have a problem, right? Now, the solution to that problem is either clear weak and we trust V8 does the right thing, or we set this Boolean and we restrict the scope of the Boolean. So we only check the Boolean if isEnv teardown is false, right? So basically what is the meaning of the Boolean? The meaning of the Boolean is finalize has already started executing, and it started executing because of env teardown. And so if this is true, and we are inside finalize and env teardown is false, then just exit, because then we know that the GC has entered when it shouldn't have, when we're already doing finalize because of env teardown, right? And so that should be safe. And in that case, it would just be like if not is env teardown and teardown finalize in progress, return, right? And then we don't need clear weak.
If the teardown finalize in progress is a member of the final reference,
yeah,
that has a chance to access a memory.
Yes. It shouldn't. It shouldn't. The reason why it shouldn't is because in your repro, when this is false, meaning that the GC comes back to do the finalize, then the class is not yet deleted. The problem the problem caused by your repro is that this does not happen. It doesn't return here. It comes here, right? And it runs the finalizer again. But even if the finalizer doesn't do anything, it gets to here, and then this actually deletes, right? And then the finalize caused by the GC returns, and the finalize caused by the environment teardown resumes right here, and it deletes again. These are even bad at that time. So we must prevent the internal, the inside finalize, not the outside. The outside finalize is okay. And the inside finalize causes problems starting here. This is where it starts causing problems. So the instance here should still be there. There's no reason that the instance should not be there. So this should be okay. You know what? It's 9/11. It's getting late. Why don't we continue the discussion next week? All right?
Yeah. Okay. Great. Awesome.
Okay, I'll create both solutions, and I'll keep this solution for now, and then I'm going to make the repro into a test, assuming I have time. I'll make the repro into a test, and then we can test both solutions, and we can run it like 1,000 times or whatever. We can even send it to the CI, and then it'll test it on like 1 million platforms, and hopefully one of them will tell us, no, that's the wrong solution. Or if they all pass, then as far as we can tell, it's an okay solution. And we can test both solutions that way. But anyway, so let's call this one. All right.
Yeah, great.
Any other burning issues, please mention them now. Otherwise, we'll call it for the week. So going once, going twice, gone. Thank you, everybody, for attending, and we'll speak again next week. Have a good one.
Thank you. Bye-bye.
Bye.
Bye.